of the function that's defined here. The function fx is equal to x cube minus x, and then we define its derivative here. F prime x equals derivative of fx comma x fxx, and after that we are trying to plot both the functions, the function fx and the derivative function. So first we determine the derivative, and it is that derivative is then stored in a separate location as a function, and it is given a separate name, and after that both functions can be plotted using this command plot fx in x minus 2 plus 2 minus 2 plus 2, then color using the color blue, plus plot f prime, that is the derivative of the function fx, f prime of x, and then x minus 2 plus 2, and then color red. So this when we apply that, when we implement that that step, then we get this curve. Both derivative and original function is plotted here, and the derivative is curve of the derivative is available here in blue color. Next we come to the problem of finding higher order derivatives. For that, the same function can be used. We are going to use the same function that we have previously defined. We have defined above fx equal to the function fx equal to x cube minus x is already defined. So you can use that function because it is already defined. Now you can, otherwise you have to, and there is no problem if you define the function again, if you repeat that step one more time. So after that you can you can type now, or if you want to show if you want to see the output, if you want to ensure that the given function is stored at the location of fx, you can use the command once again, show fx. Show fx. Taking the output, we can see that x cube minus x is the function fx, and now you can you can differentiate the function repeatedly. You can differentiate. For first differentiation, for obtaining first derivative, we step by step we differentiate the function, and we store the answer at different locations, choosing different names. So first name chosen to selected to store the function derivative of the first derivative of the function is f1x. f1x equals then dif of fx comma x. This is the command that is used. f1 of x equals dif of fx comma x. Now to display the output, either you can write f1x or show fx. You can type show f1x. Yes, the derivative, you can verify that this function, the new function which is displayed here, is the derivative of the function x cube minus x. So 3x square minus minus 1 is the derivative of this function. Now to obtain the second derivative of the given function, you can use a similar command, but with one change, with exactly one change. So the same command can be used, but in this command, f1x equal to derivative the dif of fx comma x. Then after that, after x, you have to give one more quantity you have to give, and this quantity stands for the degree of the derivative. Okay, and in the second derivative, it will tell the system whether the level of the differentiation. It can tell about the level of the differentiation. So since the level here is second level, so you can to indicate that, you can use the number 2 there. Okay, then you can just type so see here. Okay, and this is then f2x. It must be changed. So f2x, this is the second level derivative. So f2x, the function name is f2x equal to a derivative at the second level. So dif of f1x comma x comma 2, and you can display the output using show f2x, right? Yes, this show f2x gives us the answer 6x. That is the second derivative of this function. Second derivative of the function is q minus x. And if you want to differentiate it once again, and you can and if you want to store it in that value in a location, then you can use the same. You can copy and we change it to f3x, the third derivative. f3x equal to dif of f1 fx x, and the difference here you have to make is the number 3 must be changed to 3 for obtaining third derivative. For obtaining the third derivative, you can use this syntax. But this is just a name. F3x is just a name, but you can choose different names at this place. But this is but a standard part of this part cannot be changed. The syntax of the part equal to the dif of fx comma x comma 3, that cannot be changed. For obtaining third derivative, it must be the same for all type of situation. Now I am going to take the output, but for displaying f3x, you have to type show then f3x. okay, thus we have 6 as the derivative. That is the third derivative. Once again, you can take the derivative, you can find it, and then you will get 0. You must get 0. So 4x equal to 4. Okay, then after that you can use show command. That show command, you can type 4. Yes, we have obtained 0. So this is a very good example for that explains the method of finding the derivatives, higher order derivatives, continuously or higher order derivatives. Okay, next we can explain, see, how partial derivatives can be determined. Partial derivatives come into picture when the mathematical expression contains two or more variables, when the function contains two or more variables. Okay, so for that you have to specify, for defining such a function you have to specify some letters as variables. You have to specify that x and y are two variables. So for that you can use this kind of command, var, then in quotation var bracket, then quotation mark, single quotation. You have to specify the letters or symbols that can be that will be used as variables, and that letters must be separated by commas. Okay, and that step can be explained here. var, then bracket, in bracket we put comma, sorry, we use then single quotation. In it you have to state the variables. There are two variables which are going to be used here. Okay, then it displays that it has the system SAGEMATH has accepted x and y as variables. Next you can define the function. See, the function gxy is the function going to be defined as a function containing two variables. So you can type that g of x y, x comma g of x comma y equal to x star y plus sine x star y x into y plus sine of x square plus e raised to minus x. Okay, without error you have to type it, x into y plus sin. So let's repeat that, sin, then sine, okay, x in bracket, we have to correctly type x cap 2 x square, that's for x square, then e to the power, so e cap e to the power of then minus x. Okay, now that function is correct. Okay, so if you want to show to display gxy, you can use the function show show bracket and g of bracket x comma y xy. Yes, that function is displayed in its correct form, in its original form, xy plus xy plus e raised to minus x plus sine x square is the function that we have decided to define. After defining this function, we are going to find its derivative, a partial derivative with respect to x. So for obtaining partial derivative with respect to x, see, you can use the command dif of gxy, but you know that can be defined, that can be expressed as gx, and we will define a new variable that is that's given the name gx, using the name which will be represented by the name gx. That means the derivative of g with respect to x, gx. Okay, then gx of xy you can use, otherwise you can use the symbol name gx. Then it will be filled by, or it will be then stored by that derivative calculator. For finding the partial derivative with respect to x, For finding partial derivative of g with respect to x, you can write the command. Same derivative command can be used diff, but in bracket, and the defined function can be used g of xy. After that, you can give a comma. Then you have to specify the variable with which you have to differentiate. Okay. So for that, for obtaining that, you can I just type gx, then gx equals, okay, gx, or you can type gx of x comma y. That specifies the variable also. It's a name only. Gx is a name, gx of xy is a name. After that, diff for obtaining the derivative, diff, then in bracket, then I use g, x comma y. Okay, now for the function is now specified. Then put the comma, and you have to specify the variable with which we want to differentiate. Okay, then I take the output. So in the typing there is no error, since it does not show any comment here, error comment here, so it's correct, the typing is correct. Now you want to take the output, right? So for that, you can use show, show, then in bracket you can use gx of xy, that you can copy and paste it inside the bracket, and now you can take the output. Yeah, the derivative, you can see that derivative, and this is the function. And when it is differentiated with respect to x, you have y, so xy has derivative y, and this expression has derivative e raised to minus x has derivative minus of e raised to minus x. Okay, and then sin x square has derivative x into cos x square. Okay, that's correct. Now if you want to, if you can differentiate it with respect to y also, the same function can be differentiated. So for that, the command can be this command can be copied and used. It can be reused, but with the required changes, by making the required changes only. Here, since differentiation is with respect to y, the name can be changed to gy of xy. Okay, gy of xy equal to diff of gxy. That up to that level it is correct. Up to that step it is correct. Now, but the differentiation with respect to y we are going to do that. Therefore, diff of gxy, diff of derivative of diff of the function with respect to y, you can type, you have to use. Then again you can take you can use the command. Okay, after implementing that level, that level, okay, then you can use this command. You can copy that command and then paste it here. Then a show of gy actually we want to, because it is that this y derivative with respect to y. So gy of xy. Okay, that you can take the output. Can display the output. Why we are getting only x? Because you can see this is a e raised to minus x is a function which doesn't contain any y variable, and this function also contains no y variable. So derivative of these two terms becomes 0, and so in the answer derivative of only xy is remaining, that is equal to x. Now it's correct. This is a very good explanation of partial differentiation, how to obtain the partial differentiation, and how to find the partial derivatives, and then after that how to display the partial derivatives. Okay, by this we can end this session on partial, especially here we explain how to find higher order derivatives and partial derivatives. Okay, thank you.